In this lecture, we will provide an introduction to data structures. As the name suggests, a data structure is a way for storing and organizing information in a computer so that it can be retrieved and used most productively. Different kinds of data structures are meant for different kinds of applications, and some are highly specialized to specific tasks. Understanding data structures are important because data structures are used in almost every program or software system. Specific data structures are essential ingredients of many efficient algorithms. And data structures make it possible to manage huge amounts of data, such as large integrated collections of databases. Data scientists help to design, implement, and manipulate complex data structures all day, every day. Depending on what you're organizing for, there are many different approaches to holding or organizing data. In this lecture, we will cover basic data structures such as arrays, graphs and trees, linked lists, stacks, and queues. An array is the most straightforward way to hold a set of objects. In Python, an array is also called a list. It stores items in simple lists of objects. Looking up an object is fast if you know the index in the array, but slow otherwise. For example, it is fast to retrieve the 20th person in a list, but slow to find all people named Alex, since you have to look through all people. In most languages, an array cannot grow in length after being created. You must specify the length of the array up front, and it cannot be changed after that. A hash table, which is sometimes called a dictionary or a hash map, allows you to map a key to a value. This key is often a number or a string, and the value can be any type of object. This is a very useful data structure because it allows for very fast lookup unless it's poorly implemented. You might use it to map from a person's ID number to some object with other information about them. A graph is a set of nodes which are connected through edges. Not all the nodes need to be connected. You could have two entire separate subgraphs, and the edges can be either directed or indirected. A directed edge can be thought as a one-way street, with an undirected edge being like a two-way street. If the graph is directed, an edge from A to B is not an edge from B to A. Therefore, you might be able to drive from a node A to a node B, but not the other way around. The tree is a type of graph in which any two nodes are connected through one and only one path. The tree will not have any cycles since there can be only one path between any two nodes. The tree can come in many forms, but by far the most common is the binary tree. A binary tree is a tree where each node has only two child nodes. We call these nodes the left node and the right node. As with all trees, there cannot be any cycles on the tree, no path from a node back to itself. Because of these restrictions, a binary tree can be represented in a strictly hierarchical fashion. Commonly, we work with binary search trees. A binary search tree is a tree in which all nodes on the left subtree are less than the node value, which is in turn less than the values of all nodes in the right subtree. Like a binary tree, building a linked list is a data structure composed of nodes where each node has a pointer to the other nodes. In a singly linked list, the node has a pointer to the next node. In a doubly linked list, the node has pointers to its previous node and its next node. It's generally considered highly problematic and possibly a violation if the link has a cycle. A stack is a data structure which defines a precise order for how many elements must be inserted and removed. When an element is added or pushed, it is inserted on the top of the stack. When the element is removed, it is popped from the top of the stack. A stack is said to be the last in four first out or LIFO data structure, since the last, most recent element added is the first one to be removed. In this way, it acts like a stack of plates in real life. When you add a plate onto a stack of plates, you add them on the top. When you remove the plate, you always remove it from the top. Finding an element with a particular value is not usually done, as it would require removing all the elements one by one. The stack is not a good data structure choice if this is something you think you need to do. A queue is essentially the opposite of a stack. Rather than removing the newest item with LIFO or last in first out approach, it removes the oldest item. It is said to be first in, first out, or FIFO, since it's the first item you add will be the first one to remove. It acts like a queue in real life. When people are in a queue for movie tickets, the first person to get in line is the first person who will be served. This is of course how the data structure gets its name. Let's recap the takeaways. An array stores items in a simple list of objects. A hash table is sometimes called a dictionary or hash map and allows you to map a key to a value. A graph is a set of nodes which are connected through edges. A tree is a type of graph in which any two nodes are connected through one path. A linked list is a data structure composed of nodes, where each node has a pointer to the other nodes. A stack is said to be a LIFO or last in, first out data structure. A queue is said to be a FIFO or first in, first out data structure.